Okay, let's continue. Last class we started with periodic trends and properties. We did atomic radius and followed by ionic radius. Now let's move on to the next atomic property, periodic property जो हम करते हैं, and that is ionization energy, or this is also called as ionization potential या हम इसे बोलेंगे ionization enthalpy. थोड़ा सा मीनिंग में डिफरेंस है, दैट इज व्हाई वी हैव डिफरेंट नॉमेनक्लेचर, बट बेसिक is almost similar to what we have done till class 10th. I'll explain इनकी मीनिंग में क्या डिफरेंस है. Can someone tell me what was ionization energy 10th standard तक? Or can you define, someone can define ionization energy for me?
Amount of energy required.
It is the amount of energy required
To remove an electron from the outermost shell.
Now I have a question. Amount of energy, will you supply or will you remove or evolve from the atom? Supply. Indirectly what I'm trying to ask is ionization energy an endothermic property or an exothermic property? Endothermic. Because you always have to supply energy to remove the electron. Okay? So it is the amount of energy required, basically supplied to remove the most loosely bounded electron from an neutral, not necessarily neutral always, but isolated gaseous atom. I think हमने किया ये 10th standard तक. It is the amount of energy you supply to remove an electron from an isolated gaseous atom. Now, अब इसमें difference क्या है when we use the word energy to when we use the word enthalpy? See, ionization energy is something, or the term ionization energy is defined at absolute zero temperature. Now अभी तक हमको पता नहीं होगा absolute zero का मतलब क्या है, because we haven't done gaseous state. But I'll still give you, we've learned temperature in degree Celsius and in Kelvin. How much is 0 degree Celsius in Kelvin? 273 Kelvin. So what is minus 273 degrees C? 0 Kelvin. Absolute zero temperature का मतलब होता है 0 Kelvin. 0 Kelvin is a hypothetical temperature. Actually speaking, we can never reach 0 Kelvin. ठीक है, वो क्यों हम 0 Kelvin नहीं पहुंच सकते, और what happens theoretically when we reach 0 Kelvin, तब हम gaseous state में पढ़ेंगे. But it starts contradicting Heisenberg's uncertainty principle, तो वो तब पढ़ेंगे. अभी के लिए आप याद रखिए 0 Kelvin is nothing but minus 273 degrees C. Okay. And when we use the word enthalpy, so I was first wanted to understand the word enthalpy. Enthalpy is nothing but the heat associated with any reaction. It's a thermodynamic quantity, जिसको हम बोलते हैं heat of a reaction. कोई reaction में heat release होती है exothermic, कोई reaction में heat absorb होती है endothermic. Both the heat को हम बोलते हैं enthalpy, and enthalpy is actually usually measured in the form of a change in the form of amount, initial amount and final amount. इसलिए हम उसको represent करेंगे as delta H. That is enthalpy. Now, enthalpy or ionization enthalpy and ionization energy में एक relation, ionization enthalpy delta H is ionization energy plus 5/2 times R into T, where R is known as universal gas constant, T is temperature. The reason there is a parameter added here is because ionization enthalpy actual normal temperatures पे calculate की जाती है, where you have to consider some other parameters like heat capacity. 10th standard में I think we have done something called as a molar heat capacity या heat capacity, ऐसे कुछ 10th तक word पढ़ा है. The amount of heat supplied to increase the temperature by 1 degree Celsius is called as heat capacity. नहीं पढ़ा है तो भी कोई बात नहीं, फिलहाल के लिए you'll have to remember this relationship, the relation between ionization enthalpy and ionization energy. यहाँ तक with me? चलो, now let's again go back to what exactly is ionization energy. तो हम क्या कर रहे हैं people, let's say मेरे पास let's say a simple configuration is something like this. So what I'm just trying to do is I'm trying to remove this electron. अब उस लास्ट इलेक्ट्रॉन को निकालने के लिए जो एनर्जी लगती है, दैट एनर्जी इज कॉल्ड एज आयोनाइजेशन एनर्जी. इट इज एज सिंपल एज दैट. ठीक है. नाउ तो लेट्स से कि मेरे पास एक आइसोलेटेड गैसियस एटम है एंड आई रिमूव एन इलेक्ट्रॉन. सो व्हेन यू रिमूव द फर्स्ट इलेक्ट्रॉन तो उसको हम क्या बोलेंगे, आयोनाइजेशन एनर्जी 1 और IE1. And A will convert into what? Its own cation. Yes or no? Now I can remove one more electron from this. तो वो क्या बन जाएगा? A 2 plus. This will become IE2. And I keep doing that. एक और इलेक्ट्रॉन निकाल दो तो वो क्या बन जाएगा पीपल, IE. तो वो क्या हो जाएगा A, so on and so forth. So I have a question here. Do you think it is easier to remove an electron from A or it is easier to remove an electron from A plus? A. Because when you say A plus, क्या हो जाता है? When you go from A to A plus, what will happen to the size of the, अभी तो एटम से वो आयन हो जाएगा, तो कटायन का साइज इज ऑलवेज स्मॉलर द साइज. डू यू थिंक इट रिक्वायर मोर एनर्जी टू रिमूव द इलेक्ट्रॉन? वही होता है यहाँ पे, इट टेक्स मोर एनर्जी टू रिमूव द इलेक्ट्रॉन एंड हेंस आई डोंट नो ये आप 10th स्टैंडर्ड तक करते थे क्या, बट सक्सेसिव आयनाइजेशन एनर्जी ऑलवेज increases or always greater. So if I compare IE3, it will be greater than IE2, which will be greater than IE1. With me? But let's say I want to compare this. I am comparing, मेरे पास है A minus and A. Let's say the amount of energy required to remove an electron from here, I call that as IEA minus. And the amount of energy required to remove from A, I call it as IEA. Which out of the two will be greater?
E minus.
Which out of the two you will require more energy to remove an electron from? A minus कि A will require more amount of energy to remove from. Why has that A got वो minus charge क्यों आया इस पे? Because it already has that extra, so you've already added an electron. But to remove that electron is much easier compared to removing it from a आइसोलेटेड गैसियस एटम. आई रिपीट, इसके पास ऑलरेडी इलेक्ट्रॉन है. डिड यू पीपल गेट दैट? यस और नो? ठीक है. सम लेट्स से कुछ एग्जाम्पल अगर लेना है, लेट्स से अफगान है एंड आदि है. अफगान के पास 2 चॉकलेट है, आदि के पास एक ही है. आई वॉन्ट वन. whom should I take it from? Should I take it from Afghan or should I take it from Adi? Afghan, yes or no? In my case, I should actually take it from both. But electron के example, so I'll take it from Afghan. It is as simple as that. Did you will get that? ठीक है. चलो, so remember that ionization enthalpy of an anion will be less than ionization enthalpy of the parent atom. I repeat, ionization enthalpy of or ionization energy of the anion will always be less than the ionization energy of the parent atom. Next, I want to compare ionization enthalpy between the different subshells S, P, D, and F. Who do you think will have the highest ionization enthalpy? Followed by? So it's more difficult to remove an electron from the S subshell, then followed by P subshell, then followed by D subshell, and then finally from the F subshell. Okay. Now can someone give me the general trend for ionization enthalpy?
Decreases down the group.
So पहले period कर ले. Left to right in a period. Ionization enthalpy increases. Can someone tell me why does ionization enthalpy increase from left to right in a period?
Nuclear charge.
Size decreases. And और क्या होता है people?
Nuclear charge.
Z effective will increase. Getting that? ठीक है. I think basic ही कर रहे हैं अभी तक. What about down the group?
Decreases.
Ionization enthalpy or ionization energy decreases. Why does it decrease? Because what happens to the size? Size increases. Yeah, effective nuclear charge बोले तो. Can I also that? Can someone give me the relation between shielding effect and ionization energy?
Less the shielding effect, less the ionization energy.
Lesser the shielding effect, lesser the ionization energy, greater the ionization energy. Think about it. If the shield is very strong, so वो last valence shell वाले electrons हैं जो last row में बैठे हैं. If the shield is very strong, will the nucleus have any hold on the last shell? So if the shielding is strong, what about ionization enthalpy? Can I say it will be very less peak? And if I have poor shielding, what do you think ionization energy will be, people? As simple as that. ठीक है. Poor shielding है, ionization enthalpy will be greater. ठीक है. चलो एक सेकेंड ना. Okay, now let's continue with general trends. Okay, give me the elements of the second period, people. We have lithium, beryllium, boron, carbon, nitrogen, oxygen, and फ्लोरीन, इनके एक पीरियड नीचे जाता है तो कौन होगा? सोडियम, मैग्नीशियम, एल्यूमिनियम, सिलिकॉन, फॉस्फोरस, सल्फर, ये हो गया हमारा पीरियड 2, सॉरी पीरियड 3। एक और पीरियड नीचे चलता है, पीरियड 4, पोटेशियम, कैल्शियम, स्कैंडियम, बैंगन आलू गाजर ना, यहाँ पे पी ब्लॉक एलिमेंट है, ग्रुप 13, 14, 15, 16, 17, ग्रुप 1 ग्रुप, इन दोनों के बीच में डीएनएफ आता है, ठीक है। गैलियम के बाद आर्सेनिक, सेलेनियम एंड क्रोम, ठीक है, इतना काफी हो जाएगा। नाउ व्हाट्स द जनरल ट्रेंड फॉर आयनाइजेशन एंथैल्पी? हमने ट्रेंड क्या पढ़ा है? एज यू गो फ्रॉम लेफ्ट टू राइट, व्हाट हैपेंस टू द आयनाइजेशन एंथैल्पी? इट शुड इंक्रीज, तो ये ऐसा होना चाहिए, yes or no? But now what is observed is the ionization enthalpy of beryllium is greater than that of boron, magnesium is greater than that of aluminium, calcium is greater than that of gallium, and यहाँ पे आने पर in short anomaly कहाँ पे? ग्रुप, यहाँ पे मैं लिख देता हूँ ग्रुप 2, ग्रुप 3, ग्रुप 1, ग्रुप 13, 14, 15, 16, 17, 18 पे तो आ ही नहीं रहे बिकॉज वो नोबल गैसेस है। सो एलिमेंट्स ऑफ ग्रुप 2 have higher ionization enthalpy than elements of group 13, and elements of group 15 have higher ionization enthalpy than elements of group 16. यहाँ पे periodic property change हो जाती है। Before me directly giving the answer, anyone who can guess why? Let's write the electronic configuration of general electronic configuration of group 2 elements. कोई बता सकता है जनरल इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या है ग्रुप 2 की? NS2, that's the general electronic configuration. Beryllium 2s2, 3s2, 4s2. What is the general electronic configuration for group 13? NS2, NP1, एक बेरिलियम और एक बोरॉन के लिए लिख के रखते हैं। बेरिलियम का क्या आएगा पीपल? 2s2, boron is what? 2s2, 2p1. Now I have a question. Out of the two, who has stable electronic configuration? In terms of group, which group has stable electronic configuration? Group 2 या group 13? Group 2. Group 2 has stable electronic configuration. Did you get that? When you compare that with group 13, because group 13 say if you remove that p का electron, they would reach ns2, तो उनका ns complete रहेगा, and hence they'll reach a more stable state when you actually remove an electron from the np subshell over here. And that is why the ionization enthalpy of group 2 elements is greater than the ionization enthalpy of group 13 elements. Did you get that? Anyone did not understand that? Now use similar concept and tell me what happens in group 15 and group 16. What is group 15 का general electronic configuration? NS2, NP3. What is group 16 का general configuration? NS2, NP4. Same fundamental here. They have stable half-filled electronic configuration. group 15 elements have stable half-filled electronic configuration, making their ionization enthalpy more than group 16 elements. Now, it's not only this will impact IE, ionization enthalpy, it's also going to impact some other properties. With me till here? That was the first exception जो आपको याद रखना है. एक terms में ऐसे भी लिख के रखना that group 2 elements ionization enthalpy is greater than the ionization enthalpy of group 13 elements, and similarly group 15 elements have greater ionization enthalpy than group 16 elements. Next, can someone give me the elements of the first group? Alkali metals, lithium, sodium, potassium, rubidium, cesium and francium ने लिख रहे हैं, ठीक है? And the corresponding elements over here will be beryllium, magnesium, calcium. So when I go down the group, there is no anomaly. क्या हो रहा है? Ionization enthalpy. Ionization enthalpy increases. Correctly कहेंगे. Ionization enthalpy decreases. So this is a characteristics, or you can say that this property is observed in case of elements having metallic character. So elements with metallic character will have high or low ionization enthalpy.
Low.
And that is why we used such elements. अगर किसी को याद है तो these were used in which effect? To check for photoelectric effect. If you remember in photoelectric effect, हमने जो metal rod बनाया था, वह हमने potassium, rubidium और cesium लिखा था. These elements can be used because they have low ionization enthalpy. And not only that, elements with low ionization enthalpy, okay, they have metallic character and have basic oxides, or their oxides are basic in nature. On the other hand, if elements have high non-metallic character, if they have non-metallic character, उनका ionization enthalpy क्या होगा? They will have high ionization enthalpy and will have dash kind of oxides, acidic oxides. ठीक है, वो पॉइंट आप मेंशन कर लेना. अच्छा जाना, मैं लिख लेता हूँ. आई एम नॉट राइटिंग द एलिमेंट्स. इसके लिए आप एलिमेंट्स 16 और 17 के का ग्रुप लिखना पड़ता है, पर नहीं लिखेंगे तो भी चलेगा. सो एलिमेंट्स विद नॉन मेटालिक कैरेक्टर will have high ionization enthalpy and their oxides are acidic in nature. With me till here? Next. Now please give me the elements of group 13. Group 13 is boron, then aluminium, gallium, indium, and then helium. तो इट्स अ ग्रुप, आई हैव रिटन इट इन अ पीरियड फॉर्मेट और एक दो ग्रुप लिखने हैं. Now if I ask the general trend over here, general trend क्या होना चाहिए था? As you go down the group, the ionization enthalpy will decrease. Trend कुछ ऐसे होना चाहिए था. But there is an anomaly. सबसे पहला in radius. What is the trend in radius for group 13 elements? Aluminium and gallium का atomic radius is almost the same. कल हमने लिखा था ये. And that was because of what effect? Inert, excellent. Inert pair effect. So atomic radius अगर effect होगा, which means size अगर impact होगा, तो obviously it is also going to affect what? Ionization enthalpy. But now look at the trend in ionization enthalpy over here. सबसे ज़्यादा ionization enthalpy is boron. That doesn't change. But boron के बाद सबसे ज़्यादा ionization enthalpy is helium. After thallium, it is gallium. Then it is aluminium. And the lowest ionization enthalpy is for indium. That's the trend in ionization enthalpy. Now let's understand this. दो वे में आप याद रख सकते हो. Either you can remember the trend like this, or when you're going from barium to aluminium, ionization enthalpy decreases. That is correct. But when you're going from aluminium to gallium, ionization enthalpy again increases. Gallium to indium, ionization enthalpy again decreases. And we're going from indium to thallium, ionization enthalpy again. So आपको ऊपर के वे में याद रखना है या नीचे के वे में याद रखना है? Both are the same. So first anomaly यहाँ पे क्या होता है? Because gallium and aluminium का size is almost the same. Size same है, but who has higher effective nuclear charge? Gallium has higher Z effective. इसका Z effective क्यों बढ़ जाता है? Due to which effect? Inert pair. That's the first reason. Second, exactly same reason आप लिख सकते हैं for thallium and for indium. The difference in atomic radius is not much, but the increase in Z effective is very significant. I repeat, for these two, the decrease in atomic radius is not significant when compared to increase in the effective nuclear charge. So majority times कोई आपको exact reason नहीं पूछने वाले of the exception. I leave it up to you. But majority times trend exception वाले ही आएंगे. So that's the first exception, group 13. Next, group 13 के बाद can someone give me the elements of group 14? Group 14 elements please. Carbon, silicon, germanium, tin and lead. The trend should have been like this. But यहाँ पे trend में slight change हो जाता है. The trend goes correct from carbon to silicon to germanium, and then lead has more ionization enthalpy than tin. तो या तो आप उसको ऐसे पढ़ो या आप उसको ऐसे पढ़ो. And again give me the reason again. क्या reason लिखोगे यहाँ पे? inert pair effect. With me? Okay, that was group 13, group 14. Next. 3D series. The ionization enthalpy of elements in the 3D series is almost the same as the ionization enthalpy of 4D series, and यहाँ पे 4D का ionization enthalpy is greater than the elements of the 5D series. I repeat, ionization enthalpy of the 3D elements, कल हमने पूरा लिखा है 3D, 4D, 5D series, so I am not writing all of them again. 3D series का ionization enthalpy is almost the same as the ionization enthalpy of 4D series, but 3D, 4D का ionization enthalpy as you go down the group, ये anomaly है, but 4D से 5D में 4D has higher ionization energy. Did you people get that? चलो, so that was IE. एक दो पॉइंट्स और है बट उसको सम्स के साथ करते हैं. Now, the last and probably one of the most important points in ionization energy that we have, people, is it gives you the stability of oxidation state. Now, what does that mean? So let's say I'm going from aluminium to Al plus. Now, to remove that one electron, the amount of energy required was 5 electron volts. To go from Al plus to Al2 plus, the amount of energy required was how much? 7. To go from Al2 plus to Al3 plus, it is 3 electron volts. But to go from Al plus 3 to Al plus 4, how much energy was required? 25 electron volts. So people, if the difference, I repeat, if the difference in ionization energy between two successive oxidation state OS मतलब oxidation state, ठीक है, is less than 11.2 electron volts. I repeat, the difference in values between two successive oxidation states, ionization enthalpy values. तो ये जैसे 7 minus 5 is 2, ठीक है. Then to go from 7, so is mod of the difference value. So this is 4. Now when that value is small or is less than 11.2 electron volts, the higher oxidation state is more stable. I repeat, the higher oxidation state is more stable. Also, if the difference in the ionization enthalpy between two successive oxidation states is greater than 11.2 electron volts, then the lower oxidation state is more stable. ठीक है. एंड यहाँ पे थोड़ा सा मेरे को आई थिंक वैल्यू गलत लिखा है, बिकॉज सक्सेसिव आयनाइजेशन एंथैल्पीज विल ऑब्वियसली इंक्रीज. आई डोंट नो द एग्जैक्ट वैल्यू यहाँ पे, तो टेम्परेरीली मैं लिख देता हूँ 10 इलेक्ट्रॉन वोल्ट्स. नाउ टेक द डिफरेंस पीपल, व्हेन आई गो फ्रॉम 10 टू यहाँ पे क्या लिखा है 25. व्हाट इज द डिफरेंस दैट कम्स? सो व्हेन द डिफरेंस इज ग्रेटर, द लोअर ऑक्सीडेशन स्टेट विल बी more stable. Did you people get that? Now, see, you need not always, यहाँ पे आपको values memorize करने की जरूरत नहीं है. Anywhere you see a sudden doubling or tripling of ionization enthalpy value, आपको समझ आना है कि वो oxidation state probably is less stable. For example, पहला इलेक्ट्रॉन निकालने के लिए let's say some amount of energy was required. दूसरा भी some amount of energy. The energy difference will not be much. सडनली सेकंड से थर्ड निकालने के लिए 4 टाइम्स द एनर्जी इज रिक्वायर्ड. व्हाट डज दैट टेल यू? कि 2 इलेक्ट्रॉन निकालने के बाद आपका एटम एक स्टेबल स्टेट में, आपका आयन एक स्टेबल कॉन्फ़िगरेशन में पहुंच गया था. देयर वाज नो नीड टू रिमूव वन मोर. यू आर फोर्सिंग इट नाउ टू गो फ्रॉम अ स्टेबल कॉन्फ़िगरेशन to an unstable configuration, and that is why the amount of energy required will suddenly shoot up. Did you people get that? Not only this, but एक और छोटा सा point है which is not somewhere related to ionization energy, but I feel वो topic फिर भी हम कर सकते हैं. For example, let's say I talk about group 13. Can someone give me the elements of group 13? Boron, aluminium, gallium, indium and thallium. Not writing the radioactive ones. And what is the last shell configuration इनका? NS2 NP1. So if I look at boron का configuration क्या है people? Atomic number 5, 2s2 2p1. तो people, if I ask boron का सबसे stable oxidation state क्या होगा?
2s2.
I repeat, how many electrons should boron give away to become stable?
1.
It can give away this one. What do you think will be the next stable oxidation state?
2 electrons.
To not only give this one away, but also to give both the electrons away. So what are the 2 possible stable oxidation states? +3 and +1. +3 ज़्यादा stable है because helium पे पहुंच जाता है. Similarly for aluminium, what is the most stable oxidation state? +3. +1 तो दिखाता नहीं है, बट ठीक है, टेम्परेरीली हम लिख के रख रहे हैं बिकॉज थियोरेटिकली इलेक्ट्रॉनिक कॉन्फ़िगरेशन बोलते हैं +1 भी दिखा सकता है. तो गैलियम के लिए भी क्या रहेगा, इंडियम के लिए भी क्या रहेगा, एंड थेलियम के लिए भी क्या रहेगा. I go to group 14. Elements of group 14: carbon, silicon, germanium, tin, lead. Last shell configuration NS2 NP2. तो ये 2 इलेक्ट्रॉन देने के बाद इट कैन बिकम स्टेबल, और ये चारों इलेक्ट्रॉन देने के बाद इट कैन बिकम स्टेबल. सो +2 and +4. So all of them can show. I'm saying they can show. I'm not saying that they will show. छोटा सा anomaly समझेंगे इसमें. Give me the next family. Nitrogen family. Give me the elements of nitrogen family. Last shell configuration NS2. तो कोई मेरे को बता सकता है क्या क्या ऑक्सीडेशन स्टेट यहाँ पे लिखूंगा? ये 3 दे दिया तो +3, 3 + 2, तो they can also show +3 +5. एंड लास्ट एक और कर लेते हैं. ग्रुप 16 प्लीज. ऑक्सीजन, सल्फर, सेलेनियम, टेलुरियम, पोलोनियम. लास्ट सेल कॉन्फ़िगरेशन NS2NP. यहाँ पे आप लोग बताओ. थियोरेटिकल है ये, एग्जैक्ट सब स्टेबल नहीं है. जब हम इंडिविजुअल ग्रुप्स करेंगे तब वी विल डू दैट इन डिटेल. बट नाउ as you go into the lower half of the periodic table, मैं इनकी बात कर रहा हूँ. The higher oxidation state becomes less stable. लेस स्टेबल इन सर्टेन केस वो तो दिखाता भी नहीं है. In all of them, it's observed in all of them. Even in gallium, actually, germanium, arsenic, lower oxidation state थोड़ा ज़्यादा stable है compared to the higher oxidation state. And इसका भी same reason है. The reason is due to inert pair effect. I repeat, what happens because of inert pair effect? इन सब में DNF में electrons आ गए. Very poor shielding. Because of poor shielding, the electrons in the ns orbital, इनके ns orbital के electrons are not available for sharing. I repeat, the electrons in the ns orbital are not available for sharing, and that is the reason सिर्फ इनके जो p के electrons है हम वही electrons donate कर पाते और share कर पाते depending upon the type of bond that we are forming. The ns electrons are not available, and that is the anomaly that we observe in the lower half of the periodic table, and this is due to inert pair effect. आगे each group में we will study in detail stable oxidation state, stable valency and all that, but ये same ही concept बाद में फिर आ जाता है. अभी देख लो उसको. Getting that? ठीक है. That completes ionization energy, ionization enthalpy. Homework के लिए ये कुछ questions कर लेना. And next class we will start with electron affinity.